What we are discussing, chemical bonding, hybridization, and how to find out that all we have done, right?
Yes, sir, we have done.
It will be that we have done, no? Okay. Uh, Sound తగ్గించి ఇంటికి వెళ్ళిపోయావు. Okay, students. So now what we are going to discuss is, okay. After this, we need to discuss about the. I think I told you Vesper theory also, right? Valence cell electron pair repulsion theory.
Yes, sir.
Okay. Now what I'm going to do is, uh, when we started combined classes, do you remember we had given one schedule, one syllabus track we had given? Do you remember?
Yes, sir.
So as per that, we have done two topics. Okay.
Yes.
Now let me go with third topic. That is periodic table. Okay. So some of you already had this topic because for some classes this topic already I have taken as per your CBSE class. Okay, and as it is this topic is important, so I am trying to just brief it again. Okay, so listen clearly. So this topic we will finish once we complete this, then topic is our schedule is going to be finished. Okay, Nana?
Okay.
Okay. uh, how many members this topic will be a old topic? Please raise your hands. Rohan, Manogna. Okay. Pujita, let me check it in queue. Only three members only. I think this remaining all are old members, no? So let me continue. Huh? Mm. All of you can see my screen, right?
Yes.
Mm. Here, what happened here? This is not functioning. Mm. Uh, Topic is periodic table. Okay, periodic classification of elements. And you people all know why we are going to classify the elements only to study the properties of the elements and to make simplifier. Okay, to make simple only we are going to study the properties and all those points. Okay, so in the periodic table the first classification was done by uh, Dauber Einer was the first person who made classification for the periodic table. Okay, na? So Dauber Nair's traits. Dauber Nair traits. Okay, so in the Dauber Nair traits, what we can say in Dauber Nair traits, what we can say according to this. According to this, what we can say, he arranged all the atoms in a group of three. So while with increasing atomic masses, so while he is doing that, so he observed that the first element and third element average will be the second element mass. Okay, this is actually Dauber ionized triads principle. What? So when he arranged all the elements in increasing order of their atomic masses, when atoms are arranged in increasing order of their atomic mass, when atoms are arranged in increasing order of their atomic mass, okay, the mass of the middle element is the average of first and third element. Okay, for that one we are having examples like these triads you need to remember, that is iron, cobalt, nickel is one set. Okay, first triad, and second one is lithium, sodium, potassium, second set, and next one is calcium, strontium, barium, next chlorine, bromine, iodine, barium నాన్న, barium కాదు. Newlands octaves. What is Newlands octave? Generally, what he is saying. So when he is arranging all the elements in increasing order of their mass, so he observed that the atomic mass of first element and the eighth element, because the first element and the eighth element are equal. Okay, that's what we can say. When arranged in increasing order of their atomic masses, he observed that the properties of and eighth element are same. Okay, the properties of first element and eighth elements are this is just like musical octaves. Musical octaves, like what we can say: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. If I'm taking no, so this is 1, 2, 3, 4, 5, 6, 7, and eight element is he left inert gases. sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, potassium, and calcium. Okay, likewise. So now you have observed, so this entirely became one group actually. Okay, this entirely became one group. Okay, so this is what we can say about the La Newland's octaves of musical Newland's octaves or Newland's law of octaves. Next one we came into that is Mendeleev's periodic table. Okay, so Mendeleev's periodic table, so which is having Mendeleev's periodic table. So in this Mendeleev's periodic table, what we can observe is simply we can do that. See, so he observed that the physical and chemical properties of atoms. Okay, okay. So he observed that. See what we can say. If he was the first person, he gave periodic law. That means these properties also. So this type of classification also based on Mandlow's atomic mass only. But he was given the first periodic law. Periodically means the properties which depends. Okay. So according to this, the physical and chemical properties of elements are the physical and chemical properties of physical and chemical properties of elements are periodic function of their okay, elements are periodic function of their atomic masses. Okay, so this is the physical. That means he is saying that whatever the properties of elements are there, that all depends on the atomic mass of the elements only. So he is also arranging all the elements in order, and from there only he had given points certain points he had given. Okay, so according to this Mendeleev's periodic table, there are 9 vertical columns are there. Okay, there are, so in his periodic table, periodic table, there are 9 vertical columns. 9 vertical columns called
Sir, COLUMN, sir.
which one है?
Columns.
अच्छा MNS है.
Yes.
Vertical columns are called groups, and these are designated from these are designated as. Do you remember how it is designated?
Sir, is it groups and periods?
Yes, that only. So actually, the first group and period completely. The idea of group and period was completely given by I
Mendel.
Dauberner, what we can say, Mandel only. So there are total nine groups. That is okay, nine groups. That is zero to eighth groups are that all comes under nine groups only. Okay, and according to this, except okay, except zero group, each group further divided into two subgroups A and B. That means we are having 1A, 1B, 2A, 2B, 3A, 3B, likewise. Okay. Next, uh, next one we can say that according to this, uh, in his theorem there are seven horizontal rows, seven horizontal rows. There are seven horizontal rows called periods and are designated as 1, 2 up to 1, 2, let me write 1, 2, 3, 4, 5, 6, 7. Likewise, there are seven groups are there. Okay, so these are the characteristics of Mandel's periodic table. We can say okay, and now there are certain significance also there. So what is the significance? So generally, he was the first person who studied the properties of a classification properly. Okay, and next one, he corrected the atomic weights which are doubtful at the time. Okay, and one more thing, he left some places for the elements which were not known at the time. For example, let me take a so significance of Mendel's table. Okay, significance of Mendel's table. Okay, so what is this Mendel's table is uh, what we can say, uh, he corrected the doubtful atomic masses. Doubtful atomic masses. And one more thing, what he did actually, uh, he predicted some new elements and left some places. Okay, like what we can say generally, eka silicon. Eka silicon means silicon nest. Uh, this element only now called it as eka silicon is called germanium. Next, Eka aluminum. Eka means what we can say, Nana? So Eka means what we can say. It is like Eka means it is next to aluminum. That is given as a gallium. Now we are calling it as gallium. Germanium we will indicate with Ga, and gallium we will indicate with Ga. Generally, gallium is the till now we are having lowest melting point metal. Gallium having lowest melting point metal. Generally, a metal will have general highest melting point will be there, no? So in that one, gallium, what we can say, lowest melting point will be there in case of gallium. Okay. So this is what we can say about the uh, predictions and some usefulness of the points. And in that one also, there are certain defects also there in the Mandel's periodic table. స్టూడెంట్స్ అర్థమవుతుందా అందరికి కెన్ యూ కెన్ అండర్స్టాండ్ నో defects is can anyone tell me
Sir,
first
aluminum is gallium, sir.
eka aluminum next way which is coming no, that is gallium. Okay.
Okay, sir.
So once could you show the previous slide?
Yes, sir.
Done.
Yes, sir, done, sir.
Yes, sir.
First it was not given. Next one వచ్చేసరికి చూడండి. So defects లో so the position of isotopes were not given. Generally isotope means what we can say. What is meant by isotope, which we have discussed already?
Sir, different atomic mass of the same element, sir.
Isotopes means what? Same atomic number.
But
Yes,
mass.
sir. But different mass number, sir.
Very good. But different in mass number. Okay. This is one example. Next one more thing is next group 18 elements, group 8th. Okay, group 8 elements, group 8 it is, group 8 elements are not placed properly. Okay. Next వచ్చేసరికి next one, the position of lanthanides and actinides are not given. So the position of lanthanides and actinides are not given. Okay, the position of lanthanides and actinides are not given. So this is a next point. And one, this is very, very important point. So there were anomalous pairs are there. anomalous pairs. Okay, that is anomalous pairs means what we can say. Anybody having idea what is anomalous pairs? Anybody? Hello.
Yes, sir.
Do you have any idea?
No, sir.
No, sir.
Anomalous pairs means generally. So according to this theory, how the elements are placed, it
Sir,
is
can
placed.
I tell?
Tell me, Nana.
Sir, anomalous pairs are the uh, pairs of elements which have which atomic mass is not increasing, sir.
Not in increasing order. That means what we can say, there are certain elements, that is some elements, okay, with higher atomic weights, higher atomic weights, okay, with higher atomic weights, uh, precede the elements, uh, precede element with lower atomic mass. That means what we can say, so when arranging, there are certain elements are there, that atomic mass is little bit higher as compared to the next element. For example, let me take argon and potassium. First we will write argon and after that potassium. No, argon atomic mass is nearly 39.9, whereas potassium atomic mass is 39.1 only. Okay, but actually first what we need to write, we need to write potassium and after that we need to write argon. In the same way we can write cobalt and nickel also. Cobalt generally, cobalt first it will come 58.9 around, and cobalt after nickel we are getting 58.7 or 6 it will be there. So actually first we need to write nickel then cobalt. After that we need to write see here first as per the sequence what we need to write potassium and argon. But in the Mendeleev's table first it was given argon and after that potassium it was given. Okay, so these are the points and merits and demerits of modern what we can say Mendeleev's periodic table. Right. After that, Moseley's experiment was came.
Sir,
Tell me,
sir,
Nana.
ఆర్గాన్ పొటాషియం ఫస్ట్ ఆర్గాన్ ఇచ్చారు కదా సార్ కోబాల్ట్ నికెల్ కి కూడా సేమ్ ఆర్డర్ లేదా డిఫరెంట్ ఆర్డర్ ఇచ్చారు సార్
Actually, cobalt nickel could same order. First, actually, as per the atomic mass, nickel first should be written, and after that, cobalt should be written, right?
ఎస్
But actually, in his table, first cobalt was mentioned, after that, nickel was mentioned.
ఓకే సార్
Okay.
ఓకే సార్ హూ ఫౌండెడ్ దిస్ సార్
Who founded means the next Nana, while writing only next scientists are there, no? They only said. Okay. There was no specific name who identified this, right? Next one is Moseley's experiment. Any idea what is Moseley's experiment? If anybody having idea, please let me know.
Sir, it is an experiment done for the
modern periodic table that mentions the periodic properties, sir.
Yes.
It was conducted by Mosley.
Mm. Okay, so what is this experiment actually? Okay, it is like a source of
Sir,
a modern periodic table work, we can say. So from his experiment, what he did, and from that one, what we understood.
sir, can I?
Tell me.
Sir, it showed the frequency of X-rays.
Yes.
Sir, from an element from bombardment of cathode rays, sir.
Mhm. You are mixing. Okay. See what we are going to say.
It
Uh,
also identified cathode and anode rays.
listen. Generally, this is any material. Okay. Generally, he has taken some certain metals. Okay. He has taken certain metals. Okay. Actually, he is a physicist. And when these are the electrons are bombarded, that means what? High speed of electrons. High speed of electrons. So when high speed electrons are bombarded on the metal, no, there is ejection of X-rays are going to eject. X-rays rejected means which are coming from the metals. Okay, na? Are you getting what I'm trying to say? So what he observed, that is, so X-rays means what? Definitely it will have some certain frequency or not. Okay, na? Certain frequency will be there, no? That he observed, that is the frequencies of X-rays ejected when metal is bombarded with bombarded with okay, when metal is bombarded with uh, high speed of electrons. Speed of electrons. So the frequency of X-rays ejected is directly proportional to is directly proportional to atomic number of the metal. Okay, so atomic number of the metal, that is root over that he is given from his experiment only, that is frequency which is equal to a into z minus b, where nu is frequency of X-ray and z is atomic number. Z is atomic number. Next, what we can say, A and B are the constant for all the X-rays. Okay, for the A and B values are constant. B are constants, which depends on the element. Okay, so this is the formula we can write on that. Okay, so if I'm splitting this, root nu equal to Az minus Ab. Okay, so if I am plotting a graph between if I am plotting a graph between frequency here and atomic number here, tell me how graph comes. You don't know how
Sir,
to draw graphs or not?
yes, sir. Is it like parabola, sir?
No.
Sir, it will be uh, straight straight line from the origins, sir.
Actually, see, this
Diagonal.
is it is on root nu is on y-axis, right? And this is z is on x-axis and minus c. So this is like y equal to minus mx minus a, which is having like this. Okay, likewise we can have. Okay, this is like a negative interceptor, that is AB value. Okay, negative interceptor AB value we can say.
Or once can you repeat? I didn't understand.
Actually, in graph generally, you need to know. I think as you are going for higher classes now, you will find like y equal to mx graph, how it will be looks like, and y equal to mx plus c graph, and y equal to mx minus c graph, and y equal to minus mx graph. That graphs we are going to study. So, and this relation is similar to y equal to mx minus c. So, we will get graph like this. Okay. Next one is, so from that one, so the periodic law was changed. So from there, what we can say from his experiment, the modern periodic from Moseley's experiment, experiment, modern periodic table, modern periodic law is stated as what we can say, that is the the physical and physical and chemical properties are elements are periodic function of their atomic number. Okay, that means what we can say. So whether you are taking physical properties or chemical properties of any element, no, it always depends on the okay. So that atomic number or atomic mass, it will depends, right? So please, this is about the modern. So from there only, the modern periodic table. From there only, we can say that modern periodic table is reference. Okay. Okay, students, అర్థమైందమ్మా? Okay. So in tomorrow's class, we will discuss modern periodic table and how it was there. That we will discuss, and after that we can go for periodic properties. We can go. Okay, students.
Okay, sir.
Okay. Thank you all of you. Good night.
Thank you, sir. Bye, sir. Good night, sir.
Thank you, sir. Bye, sir. Good night, sir.